Hi, I'm Hakim, in charge of Android development, and this is our application. Our Android application has been designed with the best user experience. In addition, we have created our Bluetooth menu with the intent of ease of use as our main focus. Additionally, manual control of the robot is available if we wish to override the movement control. Users will be able to place up to 5 obstacles by dragging each obstacle on the grid map. Subsequently, by tapping on each obstacle, the users will be able to decide the phase of which the obstacles are placed at. Once the placement of the obstacles have been finalized, the user may easily click on the Send Obstacle button, which in turn trigger the pathfinding algorithm to the image recognition path. As the robot traverses the path, it will be updated on the map, providing a clear simulation of its location. Finally, when the robot detects the obstacle, it will show up on our map as well.
I'm Xingjie, in charge of the Robo algorithm. As our teammate HAKIM shared earlier, we would first plot 5 obstacles in Android's UI arena. Since both starting and ending points are predefined, we have chosen the A-star search algorithm to provide us with the lowest cost path. That would automatically allow our robot to move from start to the endpoint within the shortest possible time. Here is how our algo communicates with other robot segments. When Android sends the obstacle coordinates to RPi, the RPi will direct the coordinates to Argo so that the Argo can calculate the shortest path that goes through each obstacle. After the calculation, Argo will be responsible for converting the obstacle coordinates to instructions for RPi to initiate the robot movement.
Hi, I'm Min. Considering the arena provides a structured environment for the robot to navigate, we have adopted the 3-point turn method for our robot movement. This 3-point turn movement minimizes the complexity of the robot's movement algorithm, which allows the robot to change direction swiftly without the need for sophisticated calculations. This method also ensures the precise positioning of the robot within the arena grid. As the robot rotates around 3 anchor points, it maintains better control over its positions, reducing the likelihood of overshooting or even miscalculating its intended path. In addition, our robot will also go in small movements, waiting for each signal to finish first by pausing the movement before proceeding to the next. Using asynchronous programming, eventually we will target the car to continue the movement while image recognition process is still ongoing.
Hi, I'm FUYI. For our image recognition, we first started to collect about 1,000 pictures that vary in distances and angles away from the camera. To align with our robot movement strategy, in which the robot will move precisely and stop right in front of each obstacle, the dataset collected previously have been adjusted to ignore pictures that are too far away from the camera. This is to avoid the image recognition model to be oversensitive. Use the annotation tool in the RoboFlow platform. We have then labeled each picture to its respective image group. When training the YOLOVA model, we have included the scenario of original dataset without augmentation as the accuracy benchmark, with augmentation such as adding grayscale, brightness, and exposure, also adjusting the batch size and epoch in different training models. For our YOLOVA training accuracy, out of all models that we have trained, we have chosen the final model that provides us the best prediction accuracy in general.
Hi, I'm Shirley. So you all must be wondering how to build the Raspberry Pi, right? So I'm here to teach you how. So the Raspberry Pi acts as an intermediary in establishing the communication interface for all our infrastructure components. Think of it like a home router that has its own Wi-Fi module that will share the load of the connection to many devices. So for us, it's the NDP Group 2 Robo car, our MacBooks and gaming laptop. Setting up the Bluetooth as an infrared is easy peasy lah. You must establish a trust connection for your Android device and your RPi. It is like love at first sight during a matchmaking session. Then you can work on the logical connection. I've named the Python script for our Bluetooth server. You bind the server socket to a port and listen for all the connections. You must find your RPi Bluetooth address with the server socket. Next, you create a Bluetooth service record called NDP Group 2 by binding the RPi UUID. Lastly, I create a module to send data to client server via the Bluetooth channel. You are done already.